Hi guys, this is Dr. Gonzalez here, and in this lecture video I'm going to talk to you about central tendency, which is a central component of statistics. So without further ado, let's get into the topic. So central tendency refers to a single value that we use to represent the center or the typical value of a distribution. You have heard of this before in reference to the average or the mean. But as you've probably learned in other statistics courses that you've taken before this one, there are different ways that we can describe central tendency. It's not just the mean. So why is central tendency important? It takes complex data and it simplifies it down to a representative number that we can use to describe that data set, right? And then from that, I can make comparisons between groups. So for example, I can give my first period biology class an exam on protein synthesis, and I can give my fifth period biology class an exam on protein synthesis, and then I can compare the average or the means for those two groups. And in some ways, with that, I can describe how well those groups did on the test, and I can compare them. Also, central tendency tends to form the basis for a lot of other statistical analyses that we're going to do later on when we transition to inferential statistics. So the three measures of central tendency that you're probably used to have heard about in statistics are the mean, the median, and the mode. The mean is the arithmetic average or the mathematical average of that group. So it's the sum of all the scores divided by the number of scores, right? The median is the middle score, median coming from Latin for middle. And mode is the most frequent score. Each one of those measures is capturing an idea of what we would describe as the center of a data set. Each one of them also has strengths and weaknesses when it comes to selecting them as your measure of central tendency. So let's talk about the mighty mean, because everyone has heard about the mean before, and every day you probably come in contact with something that has made reference to an average, right? So the mean is the average. It's the sum of all scores divided by the number of scores. And conceptually, it represents a balance point in the distribution. So things can be above or they can be below that mean. And you'll see on this slide, I've also included the mathematical formulas for both the population mean and the sample mean. And the difference being what we're using to represent the mean itself, mu versus capital M there. Let's talk about the properties of the mean. So the mean is based on all scores. That means that every value in that data set is going to contribute to the calculation of the mean. So in that sense, it's informed well on all scores. Now that has its downfalls later on when we start talking about outliers, especially extreme outliers. So that brings us to the second point. It is sensitive to extreme scores or outliers. So that means a single value can distort your mean. So you could have 10 quiz grades in one semester, right? And grades 1 through 9 can be all 100s, but then you bombed the last quiz and you made a 50. And so it's going to bring your mean down. Third, the mean is an interpretation of that balance point. So what I was talking about earlier is it sets a level in the middle where we want our sum of deviations above to be equal to the sum of deviations below. And we'll get more into those deviations later. So you're probably asking, what's a deviation? Well, a deviation is referring to the distance a score falls from that mean. So it's a concept that we use frequently in statistics when we're calculating other statistics. So what we want is the sum of those differences to equal 0. So in other words, I want a distribution that is all 10s and the average is 10, and therefore my sum of the differences of each score minus the mean is going to equal 0. Obviously, that would be a distribution that would be not really a distribution. It would just be a data set with all of the values equaled. So when do we use the mean? We're going to use it when we're dealing with interval or ratio data. We're going to use it when we've got a distribution that is symmetrical. And if you'll remember back in my previous lecture about frequency distributions, this would be a time where a frequency distribution would inform your decision on which measure of central tendency to use. If I was looking at this data set right here, I would see I have a normal or symmetrical distribution, and so using the mean would be an adequate form of central tendency. So it is symmetrical because it has no extreme outliers. The next one that we're going to discuss is the median, and the median is the middle score when we arrange all of our data in order, ascending or descending. Either way, it's going to give you the median. How do you find it? You would order all your scores, you would locate the center point, and then if you have an odd number of scores, you're just looking for the exact middle score. And if you're looking for the median in a data set that has even numbers, you're going to find the two middle values and average them. Or more than likely, you're going to pull that median from Jamovi or SPSS or whatever you're using to analyze your data. The median is not affected by outliers, so that gives it an advantage over the mean in this aspect here. So the median is just based on those scores listed out ascending, and we find the one in the middle that divides it in half. So only your order matters. The magnitude of the scores is not coming into play. So when are we going to use the median? We're going to use it as our measure of central tendency when we have a distribution that is skewed. For example, like this one over here, you can see that it is being skewed to the left. That means most of my scores are up here towards the top. However, I have some out here that are dragging the distribution out to the left. We also use the median when we're dealing with ordinal data, and we are going to use it when we have those extreme outliers. The third form of central tendency that we're going to discuss is the mode, and the mode simply refers to the most frequently occurring score in that data set. And the mode can vary greatly depending on the data that you're dealing with. You can have unimodal, that means there's only one mode. You can have a distribution that is bimodal, and that means that it has two modes. It can be multimodal, which means it's got more than one or two modes, and then there can actually be no mode in a data set. The mode is the only measure of central tendency that we're going to use with nominal data. Remember, nominal refers to categories or names. So if we're dealing with data about class, so freshman, sophomore, junior, and senior, if I have a group of students that I'm working with in my research study and I have them grouped by their year in school, I have freshman, sophomore, junior, and senior. Those are nominal groups. The mode's easy to identify because I'm simply looking for the score that is occurring most frequently, but it has more limitations than the other two. For example, the mode ignores most of the data. In fact, you're only concentrated on that one score or whatever that is mentioned the most. And because of that, it's sometimes unstable. Now, when do we use the mode? We're going to use the mode, obviously, when we're dealing with categorical data, like freshman, sophomore, junior, and senior, male, female. And we're going to use it when we are interested in identifying the most common value or response. So let's talk about how central tendency and frequency distributions play with each other. So we are looking for the symmetrical property of our distributions. And when I say a distribution is symmetrical, that means the left side and the right side are mirror images of each other. And that means that the scores are evenly distributed or clustered around the center. So down here I have an example of the standard normal distribution. These are z-scores. This is from Graviter. And you can see that there is a peak right here at 0, and there is a nice slope on each side that is the same. So that gives me my mirror image and that symmetrical property I was looking at. So in a symmetrical distribution, you've got an equal relationship between the mean, median, and mode. So in other words, they're all equal. So if I say the mean of my data set is 5, that also means that the median and the mode are 5. And this is because I don't have any extreme scores pulling it to the right or to the left. That means my data are truly balanced. And no matter how I define the center, whether I use mean, median, or mode, it's consistent. Now, in a symmetrical distribution, the mean is going to be a valid and accurate representation of the data, and I can go ahead with that in any other statistical analyses that I want to do. The median and the mode serve to back that up and confirm that data. So in a symmetrical distribution, it doesn't matter which measure of central tendency you use because they're all telling you the same story. Now, that gets changed when we start dealing with skewed distributions. So in a skewed distribution, I have a side of the distribution that has a tail that's longer than the other. And that indicates to me that my data are not evenly distributed. So I have two examples here. I have a right skewed distribution that is having the mean, median, and mode pulled to one side. And then I have a left skewed or negatively skewed distribution, and it is showing all my data pulled to the other side. In that positive skew, I can also refer to it as right skewed. That tail extends to the right, and that means that most of my scores are low to moderate, but there are some scores on the right-hand side that are stretching out my distribution. So that means in a positively skewed distribution, the mode is less than the median, which is less than the mean. Why is this happening? Well, it's happening because the mean is being pulled towards the tail by those higher outliers. The median is going to shift slightly, but not as much, and your mode is going to stay the same at its peak. Now, in a positively skewed distribution, it means your mean is artificially inflated, and it may not be the most representative thing you can use when referring to central tendency. And a real-world example of that would be income. So in the ideal world, most of us are moderately earning our income, right? We are moderate income earners. But there are going to be some billionaires out there, right, who are extreme outliers. And because they're extreme outliers, they are making a lot more money than we are. And if we grouped everybody together and created a distribution of those scores, we would discover that our mean is higher than what we would like when we're using a representation of central tendency. So the mean is not accurately representing a typical person. Median, in that case, would probably be a better measure of central tendency. Now, all of the stuff that I just said in regard to positive skew, the opposite's going to be true in negative skew or left skew. I'm going to have a tail extending to the left. Most of my scores are going to be high, but there are going to be some scores on the lower end that are stretching out the distribution. And this should actually say negative right here. So with a negative skew, I'm going to have mean less than median less than mode. So why is it skewed? It's skewed because those low outliers on the left-hand side are pulling everything downward. Our median is going to shift slightly, and our mode is going to remain near peak. A real-world example of this would be a super easy exam that I gave on the fly to my, my third period biology class right now. Most of those guys that I'm teaching at the moment in that biology course are wonderful, on par, and a pop quiz would be nothing for them to struggle with, right? But I've got one or two sleepers, and they're not very engaged, and they're not going to score well on it no matter what. So most of my students would be over here on the right-hand side of that distribution, but those sleepers that are guessing are going to score lower, and that's going to create a tail. And the median, again, would be a better measure here when talking about central tendency. So to summarize, we've got our mean, median, and mode. They are all measures of central tendency. Our mean is going to be influenced by extreme values because remember, it's fed by all values. Our median, on the other hand, is going to be resistant to distortion, and mode is going to be the one that we have to use when we're dealing with categorical data. And the bottom line is, when you are picking your measure of central tendency, you have to examine the skew, and that skew, which represents the shape, determines which measure is going to be appropriate. I hope you enjoyed that brief introduction to central tendency, and I look forward to talking to you again in the next video. Take care.